Good afternoon, everyone, and thank you for joining us for our Beyond Hyperconverged webinar, introducing our new product, Cloudistics Ignite. We are really excited to present the vision, technology, and benefits of our superconverged hybrid cloud platform and show you the simplicity of Ignite's control portal. Our solutions architect, Carmelo, will present the solution and technology, followed by our CXO, Partha, who will present the demo. We have a couple fun prizes if you haven't seen already. We have two winners that will win the DV Power Predator FPV quadcopter drone that actually has an HD camera with it. All you have to do is fill out the survey at the end of the webinar and make sure to tweet as well. Those who tweet at Cloudistics with the hashtag BeyondHCI, the most frequently will be higher in the list to win one of the drones. We will also announce the winner at the beginning of next week. So now I'm going to hand it off to Carmelo, who will present the vision, technology, and the benefits of Cloudistics Ignite.
Thank you very much, Tessa, and thank you guys for joining. I kind of start off with, the business's journey to the cloud. Why are enterprises going to the cloud? The first reason I hear the most is ease of use. The next reason is pay-as-you-go, and the last reason is elastic scaling. And that seems to be the main or the most compelling of all the reasons people go to public cloud that I hear the most often. And then what do you expect from a private cloud in the enterprise? The number one reason for private cloud, or at least what I hear, is I need to control my data. I need to make sure that the wrong person doesn't get access to the wrong application. The next thing is I need predictable costs. When I go into the cloud and I have an event that causes me to burst from a performance perspective, I don't know what my bill's going to look like, and it's usually not what I budgeted. And that's really hard for me to manage. And then the last thing is I need predictable performance. How many times have you had applications that run one way and then the next day, because the workload in a shared environment changes? Those are kind of the main reasons why people think about the private cloud. And the combination of these two compelling technology shifts is changing the data center as we know it. And with that, now let's talk about the data center today and kind of the data center of yesterday. And then we'll talk about where we're trying to go. So today, or really yesterday, but in larger environments that still exist and is very prevalent, you had the concept of distributed systems. It was the first real scale out of the x86 platforms in the data center. We had a lot of big vendors like IBM, EMC, Sun, HP, Cisco, Dell, NetApp. They all were a piece of whatever the solution was within the environment. And then VMware came out. And when VMware hit the street in the distributed systems world, it would cost about $5,000 a virtual machine to run in an environment like that, which was still a lot cheaper than spending $50,000 or $60,000 per server. And after that, there was this huge wave that came in 2007 with converged infrastructure. And VCE really defined this. And what VCE was and is was a combination of EMC, VMware, and Cisco. And what they did is they said, we're going to take the components that are most popular in the data center and integrate those together and build them at the factory to save you time. And from there, we've seen all kinds of CI stacks come out in the marketplace, like FlexPods with NetApp and Cisco. We've seen Dell's converged infrastructure. We've seen Moonshot from HP. And they're very prevalent, and they're actually very successful, and costs are decreasing over time with solutions like that. Then in 2012, we saw the emergence of Hyperconverged. And that's really where they combined storage and compute into one platform. And wow, this was a big change in the data center. It drove down the cost of a VM to about $1,000 a VM, and it made life simpler. And it's funny because here at Cloudistics, we like the concept of convergence, but we don't really think that converging storage and compute was the right way to do it first. And with that, we've created what we call superconverged infrastructure. And there's two benefits of superconverged infrastructure. We'll drive down your costs. Our average cost for a VM is about $500. That's half the cost of an HCI platform. And then the second thing, which is almost what I would say the most important thing about our platform, is we believe you actually have to look at the network. So when you look at any data center today, if that network isn't deployed right, everything else stops working. The storage, the compute, and that still holds true even if you're using a hyperconverged solution. And that's where we started. So when you think about what infrastructure looks like today, we talk about a lot of different waves in the data center, which some people will call that platform 1, platform 2, and we're starting to hear this concept of platform 3. But really what we've been seeing is a lot of infrastructures have switches, load balancers, firewalls, servers with hypervisors, some form of shared storage, some type of backup with a dedupe capability, SSD arrays, high performance applications need storage caching. And we looked at all those things, which are extremely, extremely complicated and hard to manage, and also cause a lot of data center sprawl, and are very hard to troubleshoot. And we said, this can be different. And when we thought about different, we created what we called Superconverged. And at the heart of our Superconverged platform is our adaptive overlay network, AON. And really what that means for you is that we do network virtualization in hardware instead of in software with encapsulation. So you get network virtualization at wire speed on the ASIC of a switch. And then after that, we said, should we do a general purpose hypervisor like a VMware or a Hyper-V, or should we build our own? So back in 2013, we made a strategic decision to build our own. And that's the Adaptive Operating System, or AOS. And what we did there is we took KVM and we changed it and we molded it. That's so it would integrate with our adaptive overlay network. And then when we were done with that, we really thought about it and we said, again, should we support everybody's storage? If we do that, though, we can't really guarantee any performance because the mileage will vary. So we created Elastic Block Flash, which is a software-defined storage capability that's on top of an all-flash hardware platform that has redundant controllers. So now I kind of gave you a high-level overview of what we do. Now let's talk about AON, which is our adaptive overlay network. So again, layer 3 virtualization in hardware without encapsulation. So we looked at how a lot of the existing software-defined networking capabilities are done today, and that's with layer 2 technology. And what they're doing there is they're taking a packet and they're putting more information on top of the packet, which forces you to send 2 packets for every 1 real network packet. And there's a lot of overhead with that. You need capabilities like VXLAN offload at the host level. You need capabilities on the switch like a VTAP. And in most environments today, if you really want to deploy a solution like NSX, you've got to refresh the server and the network, or the performance issues around deploying on legacy infrastructure make it so you can't achieve what you're trying to achieve with NSX. And that's why we did it differently. And then from there, we started looking at things like, can we provide NAT and firewall capabilities and load balancers on the switch, since we have all this extra performance in the ASIC? And we did. And there's a lot of benefit you get from that. You get all these microservices, and you get virtualization with line rate performance, operational simplicity. And you end up with microsegmentation with microservices, which enable you to secure the data center and provide more services from a single place, instead of having all these disparate vendors like Checkpoint or Cisco with firewalls, or F5 for load balancers that get complicated and very hard to manage. So from there, we moved on to the adaptive operating system. Again, it's our KVM-based hypervisor. We've made a lot of changes to it to improve it. The first thing we looked at is there's some basic features you have to have in a hypervisor to kind of play at this game today. So we've got vMotion, we've got node-based HA, and here's something we have that a lot of people don't have. And we thought this was really, really important, is we let you hot plug CPU and memory resources into your VM without having to reboot it. That's really, really compelling, because now when you have performance issues in the VM, you can add memory and compute and increase the performance of the VM while the application's running, which is amazing. At least I think it is. And what you really get from that is VM-based agility, you get data center resiliency, and you can add resources on demand. And there are a lot of workloads we're starting to see with this. We're seeing a lot of hybrid cloud, where people want to run on us and also run in Amazon. We're seeing database workloads that have never been able to run in a hypervisor environment before deployed on us. The other unique thing we've done is we've enabled native Docker container support into our hypervisor. Now this is something else that no one else does. So now you can pull your containers out of the cloud and run them local. That's amazing. And then the last thing, and we're seeing it all the time, is VDI, because it's one of the unique infrastructures where you've got to buy network, compute, and storage together for a new application. And we're an awesome fit for that. So the last thing, and this is near and dear to my heart, 15 years of my 20-year career so far was on storage. So when I saw this, I was amazed. So you have Elastic Block Flash, or EBF. We're an all-flash block capability that scales through federation. And what I mean by federation is I start with one flash block, and when I run out of capacity, I add another flash block. But in every block, it comes with its own set of controllers, so your performance is guaranteed per block, and it scales linearly. And with that, you present raw block runs directly to the hypervisor. And the reason why I'm saying this is a lot of our competitors put file systems between the virtual machines and the actual storage, and a lot of our competitors' storage arrays have log-structured file systems. So everybody gets the IOPS that they're promised, but they never really talk about the latency. And I truly believe that the market's shifting. IOPS are a thing of the past. Everybody can have flash drives, and they can do a lot of IOPS, but very few people do it in a way that they minimize latency. So let's talk about what that really means. In our array, you get VM-based snapshots instead of LUN-based or data store-based. So you get the granularity you want and the control you need at the VM level or at the application level. In every 2U, we guarantee 250,000 IOPS and 112 usable terabytes of flash before dedupe. We have dedupe, but we want to make sure you know in 2U, you get the most usable flash compared to anybody else on the market. And then the last thing is we do always on thin provisioning. So we make sure that you only store the data you need to store instead of the zeros. And that's important when you're doing flash. We know flash costs a little bit more. So we got to make sure that it's optimized and that you use it correctly. And what does that mean for you? You get 5 times the performance you're used to for your applications. We remove 8 times the latency, which really equates to overhead. And again, we lower your latency, which improves application performance. So now let's talk about the glue. So I've talked about all the things independently. And one thing I want to make sure you know about before I really focus in on the Ignite control portal is that you can scale any component you wanted independently. If I need more network, I add more network. If I need more compute, I add more compute. If I need more storage, I add more storage. You don't have to scale things in blocks. I don't have to add a server and storage at the same time. You get flexibility. And again, that is that super converged concept. That is Ignite. Now let's talk about the portal. So we give you a single pane of glass that talks to every piece of the environment and lets you gain real-time analytics and alerts about the applications as they're running. Gives you an application marketplace. And what I mean by application marketplace is we actually have a public marketplace like in Amazon where you can go and you can pick VMs and you can download them into your environment, where you create a private marketplace that's only within your data center. And it has the templates you've built on your own, but gives you the flexibility to go retrieve new applications from the cloud and deploy them locally in your infrastructure. And then the last thing, and this is kind of one of the most important things, I remember when I used to manage a data center, every time I had to do an upgrade, it was about every 6 months because I had the scheduled maintenance window. There was always downtime, and sometimes it was a whole weekend, which meant my whole staff and myself, after working the first week of that month, would then have to sit there the whole freaking weekend for 12 or 14 hours and deal with upgrades. And we'd have multiple vendors in with customer engineers. The firmware upgrades would never work the first time. We had to worry about backup plans. Man, the headache I had from doing that, oh, I'm so glad it's over. So with that, let me talk about what we mean with automatic updates. So our Ignite control portal lives in the cloud. And that portal is talking to your infrastructure every second. And we use that as a delivery mechanism for upgrades and updates to your environment. So we're an agile-based shop, and every 30 days we release something. And it comes from that portal into your environment and gives you the ability to use new features and gain bug fixes non-disruptively. Yes, non-disruptively. You don't have to shut anything down. You don't have to have scheduled maintenance windows anymore. We'll automatically live update your environment on the fly, and you won't have those problems anymore. And we can even do that all the way down to the hypervisor. We can upgrade the binaries on the hypervisor without having to reboot the actual server. That's a breakthrough for me. I can't tell you how many times I've rebooted my ESX host because I had to do an upgrade. And then those VMs didn't fail over like they were supposed to, and now I had to restore from a snapshot. Again, these headaches that I knew about are gone, and I'm so happy. I finally have my aspirin, so to say. So what does that mean for you? I can deploy my apps in minutes. It's extremely easy to use, and I finally get feature agility. And what I mean by feature agility is as these new features come out, you already have them. In your base license, when you procure our solution, you get the features. So anytime there's something new, you don't have to worry about some sales rep knocking on your door saying, hey, you know that new thing you wish you had? Well, now you got to buy more. It just comes with the box. So lastly, I think about this all the time. How long should it take to deploy an application from the time I cut a PO to the time the infrastructure's up? I remember distributed systems. And it's funny, when you think about the larger enterprises today, they still very much are distributed system environments, more so than there are conversion infrastructure. And I remember with that methodology, it would take me 9 months to get anything done. Oh man, and when I say anything, I mean I would have to deploy Oracle. I'd have 4 or 6 nodes in the Oracle rack cluster running ASM. I'd have to deploy the storage. I'd have to deploy the network. I'd have to work across many different groups within the company I was at the time. And it would take me so long just to get permission to do anything within the change window that I asked for. Oh, man, that was just brutal. And then I remember converged infrastructure. That was a huge change. Actually, it made my life better. I remember living through this change. It would cut that window down by about 30 and 40% because they would pre-ship the infrastructure already racked, already cabled, and with a certain amount of the software preloaded and ready to go. So now I went from 9 months to about 5 months, and life got better. And then Hyperconverged hit the market, and I tell you what, it was a great beginning because they really make it easier. You know, you cut a PO, 10 days later, you get your infrastructure on site. Within the first week, you get it up and going, you get it on the network. It takes about 30 to 60 days to move all the applications on, and you're ready to go in 90 days. Pretty amazing. But now let me tell you about Superconverged. And again, Superconverged is what Cloudistics is about. You cut a PO. Within 3 days, our equipment's at your door. It comes with an engineer. The engineer spends 30 minutes and your environment's up. He spends the next day and a half helping you do knowledge transfer and maybe move over the first 5 or 6 apps. It's pretty amazing. And what you get in that deployment in 5 days or less, which you won't get with the other deployments I mentioned earlier, is you get a multi-site single pane of glass to manage everything. You get a software-defined network, which isn't even talked about in the other deployment infrastructures. You get built-in Docker containers, and it all rides on top of software-defined flash storage. So you never have to worry about a performance problem again, and you get to deploy things quicker than you ever have before. So the last thing, how the hell do I start? Where do I finish? So the one thing we want to make sure you know, this is not a rip and replace strategy. This is a side-by-side deployment that as your equipment ages or you need new application infrastructure, you stand up Ignite. You can import existing VMDKs and move those workloads from the legacy infrastructure onto the Ignite platform. You can deploy new applications on containers day one. We want to give you the easiest way to adopt our technology in your environment and learn how it fits, help you reorganize the business or transform the IT infrastructure process. That's so you can enable quicker app deployment, agility in the data center, and again, a lower cost of ownership. So the last thing, and I get asked this all the time, Carmelo, you said, where do I start? How do I finish? So here's how you start. In a base unit, you start with as little as 2 blades, 256 gig of RAM, 40 cores on top of 12 terabytes of flash. We see most customers run about 100 VMs on top of this environment. And that's your base unit. Now, how do I scale? Do I have to grow everything together? When I need storage, do I got to buy compute? When I need compute, do I got to buy storage? You don't. You can scale compute independently. And you can scale with compute blocks. And within those blocks, you can have up to 4 terabytes of RAM and 224 cores in 2U. That density is second to none. You won't find it anywhere else. And if you need more storage, you just add another storage block. That block can scale up to 112 terabytes internally in 2U and give you 250,000 IOPS, and you can add as many blocks as you need to. We are elastic. We are just like the cloud. And what we found in a single rack is that a customer can get up to 36 terabytes of memory, over 2,000 cores, over a petabyte of flash, over 2 million IOPS in one rack with compute, and run about 8,000 virtual machines in a single rack. You know, I just don't know if anybody else can do this, but I know we can, and that's important to remember. Now we're going to talk about a demo. So I've talked a lot about this. The other day I actually said, I'm from Missouri on this. And I found out that half the people in the room didn't know what I meant. So just in case, Missouri is the show me state. So now we're going to show you. And with that, Partha, can you take it away?
Hello everyone, thank you for joining us today. I am Partha, and in this demo, I will walk you through the day in the life of an administrator of an Ignite hybrid cloud. But first, let me give you a bit of context on the Ignite platform. Ignite runs side by side with your current infrastructure. All we need is power, 110 volts or 220 volts, and a connection from the Ignite SDN router to your switch, and we are up and running. This screen here is our Ignite control portal. It is a SaaS offering that is accessible from anywhere in the world at any time. Using this control portal, you can manage everything, including multi-site infrastructures, without poking any firewall holes in your network. This is the same portal an administrator would use on day one to, say, register the Ignite hardware, allocate resources, and deploy applications. You can see the flow for registration and setup in a separate video on our website, Cloudistics.com. So let's walk through the experience of an administrator after the infrastructure is up and running, applications are deployed, and people are using those applications. I will spend the first part of the demo going over the different views in this control portal, and then I will go over a few common scenarios such as creating new allocations, deploying new applications, and setting up virtual networking to show how easy it is for an administrator to use the Ignite platform. So what you're seeing here is the dashboard that gives you a complete bird's eye view of your entire infrastructure and its resources in a single pane of glass management portal. It shows the utilization and status of both physical and virtual resources. The two types of physical resources we see here are compute and storage. We will jump to networks in a little bit. In Ignite, compute resources are organized into migration zones. A migration zone is a set of hosts that have a fence around them. When you deploy applications, you specify a migration zone, and once you do that, that application will only run and migrate among hosts in that migration zone. Since we are located in Reston, Virginia, we named this migration zone Reston MZ, and it is comprised of a total of 64 cores and 256 gig of memory. The next widget here is a storage one. In Ignite, storage is organized into flash pools. Our flash pools are accessible by all hosts in the infrastructure. They are all flash, highly performant, and elastic block storage. Because it's all flash and block based, Ignite delivers sub-millisecond latency and millions of IOPS. Every VM in the infrastructure has direct access to the flash pool, and that makes I/O really fast. In this demo environment, we are barely using any storage because we have disk level dedupe and thin provisioning built in. Because of this, for workloads like VDI, for example, all applications literally use a single instance on disk and result in tremendous space savings. Ignite also comes with more storage capabilities like federation and snapshots. We made all these features very easy to use, and they're all integrated and baked into the Ignite platform already. Moving on the virtual side, we have 3 virtual data centers. A virtual data center is an allocation of compute and storage to a business unit. This demo infrastructure has 3 virtual data centers: desktop services, infrastructure services, and production. Looks like the desktop services data center is running pretty close to capacity on the compute side and may need more resources soon. We'll come back to that in a little bit. But let's take a look at the underlying hardware in this environment. This page here is the hardware dashboard. This is the page where you would register your hardware assets on day one. After registration, this is where you would see all your hardware assets and their health status. Because we control the hardware, firmware, and software, we get a complete picture of hardware connectivity in any infrastructure. This is the One New Ignite SDN router and its port configuration. You can mouse over any port and see what asset is connected to that port. We made this so easy you don't have to worry about even labeling your cables. This is also very helpful to troubleshoot any misconfigurations during setup. We built intelligence into our stack to directly pull all hardware assets that are connected to our SDN router. So we can see the compute chassis with 2 hosts and storage chassis with 4 disks. You can slot in more hosts or disks as your needs grow. And when you run out of space in one chassis, you can add an additional one and keep growing. You can mouse over different devices on this page and get hardware health. For example, when you mouse over the dual redundant power supplies or cooling fans or disks, you see their health status. Also, because we are a SaaS offering, if any one of these devices reaches end of life or if they fail for whatever reason, we automatically detect that and send you replacements. When you add hosts or storage blocks and register them, they're all aggregated into a liquid pool that can be allocated to business units, what we call virtual data centers. You can see a view of the liquid pool of resources and all allocations here in the allocations page. In the hardware page, we saw 2 hosts of 32 cores and 128 gig of memory each in the rest and migration zone. And now they're aggregated into 64 cores and 256 gig here, a liquid pool, so to speak. Those and the storage resources in the form of rest and flash pool are allocated to these 3 virtual data centers now. We will come back to this page a bit to create a new virtual data center, but first let's go through a couple of other views. The next view here is the virtual networks view. Our virtual networks are very powerful and secure your applications by micro-segmenting them into their own network. These virtual networks even include their own software-based firewalls and microservices. In fact, Ignite is the only solution that offers completely software-defined virtual networks that operate at line rates, so they're incredibly fast as well. In this demo infrastructure, for example, we have one VNet called Desktop Microsegmentation VNet. This VNet segments all network traffic of applications running within it, and it is currently in use by applications in the Desktop Services Virtual Data Center. We'll come back to this page in a bit to create a new virtual network, but first, let's walk through some typical scenarios an administrator may encounter on a day-to-day basis. Let's go back to the dashboard. We noticed that the virtual data center desktop services seems to be running close to capacity. Let's see what applications are running in this data center. These are all the desktop application instances that are running in this virtual data center. Imagine a scenario where we need to add more capacity to this data center. Let's say we want to increase the resources here by 12 cores and 24 gigs of memory. And this is how we do it. We click on the resources tab and we edit allocations and we bump it up. And there, it is done. With Ignite, allocating more resources to a business unit is as simple as that. It takes less than a minute to do. Let's go over another common scenario. Let's say we got another service request. This time it's from the DevOps group, and they're asking for an environment to experiment and test some solutions. The request was to create a new business unit with its own private network and to deploy 2 specific applications. Typically, in other infrastructure setups, this would involve very complex workflows and configurations, and it will typically span multiple management silos and systems. It would take 3 to 4 people, say a network admin, an infrastructure admin, and most likely a storage admin, weeks and months to implement. Using Ignite, it can be done by a single generalist. Let's see how. Let's create a new virtual data center. I will call it DevOps. I will allocate 24 cores, 50 gigs of memory, and 3 terabytes of storage. Now, the DevOps team has these compute and storage resources to experiment with. They're self-sufficient, so to speak. Let's also set up a secure virtual network for the DevOps so their traffic is fenced off from that of your other applications. This is called microsegmentation. For that, we will go to the network virtual networks tab, and we'll select create new private VNet. We will give it a name, DevOps VNet. We will give it a unique IP address range. We'll specify the net mask and default gateway. What this means is that all traffic of any application that uses this VNet will be within this range and within this broadcast domain. I will also pick the location where I want the microservices application of this VNet to run. What I mean by that is when you create a virtual network, we automatically deploy a microservice for that virtual network. For example, for this virtual network, we are specifying a DHCP microservice. This microservice is configured using these parameters, and any applications that use this VNet will be serviced by this microservice. Our VNets also come with built-in software firewalls. You can specify a set of firewall rules for the VNet, and any application that uses the VNet will be bound by those rules. Also, unlike a physical firewall solution where all network traffic needs to go to a single device, which could potentially become a choke point in the network, Ignite does firewalls in a distributed fashion, meaning all our hypervisors in the infrastructure act as firewall enforcers, so that removes any single choke point on the network. Furthermore, these VNets are as performant as a physical network because of our patented network virtualization technology that operates at full line rates. Unlike VMware's virtual networking, there is no need for any additional virtual routers or virtual switches or lengthy period of configuration and messing around with settings. Ignite's VNets are a simple way of achieving complete network isolation and segmentation for the different business groups in your organization. It is the next wave in infrastructure security, and all those capabilities are already directly built into the product. Now it's time to deploy the requested DevOps application for this virtual data center. How do we deploy applications in Ignite? This page here shows all the application instances running on the infrastructure. You can create new instances in Ignite by using one of the following options. You can create a brand new instance from scratch using a custom ISO, or you can import an existing VMware or Hyper-V file. From any one of the instances that you create, you can create a template. Template is a sysprepped Goldmaster image that you can use to create new application instances. All the templates you create are saved locally on your Ignite hardware and are available only to your organization. You can see them here. Apart from the templates that you create yourself, you can also download templates from the Cloudistics global marketplace. Currently, we have templates for the most common enterprise applications, and we are constantly adding new ones to this list. You can see all popular Windows applications, server and desktop versions, including Windows 7 and 10. And obviously, all the Linux applications are here as well. We envision opening this global marketplace to third parties so they can host their own applications as templates here pretty soon. So let's get back to our local template store. For our DevOps environment, there was a request to deploy an instance of CentOS 7 and an instance of SQL. Let's deploy them by clicking on the New Instance button for these templates. You give the application instance a name, say DevOps CentOS 7, because your service request was for the DevOps data center. Pick that data center, which in case would be DevOps. Because this infrastructure has only one migration zone, I will select that. I will leave the default provisioning of 2 cores and 4 gig of memory unchanged for this instance. This template was set up with one disk of 80 gig, which will be automatically carved out when I instantiate this application, so I don't need to change anything there. As we described, all applications in this DevOps virtual data center must be fenced behind a virtual network called DevOps VNet. So I will select that for this application instance. This app is now up and running. I can console into it by clicking on this icon here. So there was also a request to deploy a SQL application. So let's repeat this sequence for the SQL instance. I go back to the templates and click on new instance. Let's name it DevOps SQL. I pick Data Center DevOps, use the default provisioning of resources, and run it through the DevOps VNet. So wrapping up, we were able to allocate more resources to an existing virtual data center. We created a new virtual data center. We created a new virtual network and deployed application just in a matter of minutes. As you can see, the simplicity of our portal enables a single generalist to configure your infrastructure and deploy, manage, and monitor applications, enhancing agility and productivity of your business. Think of this capability of creating a virtual data center and a virtual network as a public cloud. When I created this virtual data center, we sliced up some resources and allocated them to a group of DevOps users who can consume it just as if it was a public cloud. They would just log into the portal and deploy applications by provisioning compute, storage, and network without having to come back to the administrator for each application. So the whole thesis of Ignite is to make the infrastructure as transparent and simple as the public cloud, so your employees can focus on the business at hand. They can focus on innovating on their IP instead of managing their IT, as we like to say. With that, I conclude this demo. I hope this was helpful. Thank you all for watching.
All right, guys, we have a couple questions. So the first question we have is, can you really scale resources independently?
Yeah, so let me tell you about that. So what we did and what you can do as a customer is our compute is completely separate. It's actually in a separate chassis from the storage capability. So you can first scale compute independently. We have 3 different node types. You can have a 20-core node, a 24-core node, or a 28-core node that can have between 128 gig of RAM and 512 gig of RAM. After the first 2 nodes in your initial Ignite platform, you can add a single node as needed and scale up to 8 nodes within a chassis, and then you can add multiple chassis with multiple nodes within it. Now I'm going to talk about the storage. So with the storage, it is a separate 2U appliance. It has 2 storage controllers. It has a minimum of 4 4-terabyte drives, so you always get your 12 terabytes usable when you start. And you can add drives as needed until you get to 32 drives within the 2U controller. And once you grow out of that appliance, you can then add another appliance, and it will automatically federate with the first one. And you start with your first 4 drives, and you can add up to 32, and you can do this over and over again until you meet the need that you have.
Great. So the next question we have coming in is how does Ignite compare to Rackspace, OpenStack Private Cloud, and Microsoft Azure Stack Private Cloud?
Wow, that's a great question. So it's funny, I look at what Rackspace is doing, and they're taking the environment that they have in the data center and they're integrating it into a very specific hardware set, and they're selling it to their customers. We may look and feel like them, but there's no unique IP in the solution that they built. There's no software-defined networking. If you do, you have to do like OpenFlow, you have to do virtual switches, and the performance is very different. And we know this because we've tested it. It's just not the same as us. When I look at Microsoft Azure, or the private stack, or I'm sorry, the Azure pack, I say they might be the closest to us, but they're using storage spaces. And with storage spaces, you have to keep multiple copies of your data. So when you buy a petabyte of storage, you're lucky if you get 250 terabytes usable. When you look at us, when I buy a petabyte of storage, I get almost 80% of that storage is usable, and it's more performance driven. So I really see us having the same features and functions, but what's going to separate us is the performance of our solution, and then lastly, the portal. So if you look at Azure Pack or you look at Rackspace, you have to spend a certain amount of time to deploy their management stack within your infrastructure, and then you have to integrate it into everything you have. When you look at Ignite, the portal's already deployed and it's in the cloud, which means you don't have to do all that work anymore. You just have to turn on the infrastructure, register it with the portal, and then deploy your applications. So I see comparisons, but I definitely don't see a competitor.
Great. So the next question is, when you provision a Windows system, how does it get configured for domain?
So the first thing that we do is we sysprep the host as part of the provisioning process. So you have to add your OEM-based key, and then at that point, we can script the addition of that node into an existing Active Directory environment, or the user can do it manually.
Great. So the last question we have is, how does this offering differentiate itself from Nutanix?
That's a great question. Let's start with the beginning. We have a software-defined network. What do they got? Not a whole lot there. We have decoupled storage, even though it's software-defined, so it scales independently. The other thing, the biggest difference, the number one thing that really separates us, is when you scale a Nutanix cluster, you're mirroring your data across nodes. And as you have more data or more write-based traffic, you have to do two-phase commits across those nodes on your network, and you're stealing resources away from your applications that need to use the same network, and then you're fighting for the same compute resources within that appliance, because you have a VM running their storage capability and a VM on the same appliance running the application. Because we decouple those, you do not have the overhead on your CPUs that run your VMs for that storage capability. And we do not have all that storage traffic just to do two-phase commits as if it was synchronous replication within your network anymore. We perform like a traditional array, and we perform a lot faster.
Great. So the final question is, how do I get a POC?
Oh, that's a great question. That's actually my favorite question, let me tell you that. So we have two different ways. First, you got to get a hold of one of our sales reps. Once you get that guy on the phone, we can schedule time in a virtual lab, which is a shared environment back here at Cloudistics in Reston, Virginia, that will create a user ID and a password for you, and you can do whatever you want. If you're a qualified customer, we can do an on-site proof of concept where we'll put our equipment there, and we'll let you test it in any way you want for up to 60 days. Kind of awesome, and there's no cost to you to do this. The only thing we want to do is qualify the workload and the applications you're going to put on it to make sure that we know it'll work right for you.
Great. Well, thank you everybody for participating in the Beyond Hyperconverged webinar. Please make sure not to exit out of the browser, because that's where the survey will pop up. So please fill that in order to win that drone. We will definitely be announcing that next week, so keep your eyes out for that. And we hope you're as excited as we are about Ignite, and we look forward to working with you guys in the future.